All right. Good morning, guys. Good morning, Michaela.
Good morning.
We're gonna slowly start with this webinar on predictive maintenance, what we call the unfolding maintenance and its new value creation opportunities. Where Michaela, my good colleague, is gonna talk to you a bit about the potentials of this. But before that, my name is Mikkel, and we are, Michaela and I, we are sitting here in Hørsholm, in our demo lab, as we call it, which is our IoT design lab. Of course, we are in Force Technology, and we are in the business unit of IoT, data service and innovation. So it's all of the expertise of IoT that's been gathered in this new business unit in Force Technology. And a few words about the new lab that we've created and are located in right now. So it's our IoT design lab for both figuring out and exploring new opportunities within IoT, understanding the possibilities, combining those different technologies that we have displayed around in the lab, and combining that with potentials of business models and demos to show the possibilities and unfold this sometimes black box of IoT and electronics. But we would have loved to we would have loved to see you guys in here physically, but that's gonna have to wait until another time. But I'd like to extend an open invitation for everybody to reach out to us and come and visit and see all the different demos and partner solutions and opportunities out here. This presentation is a second in a series of webinars. Michele, he also was a part of the first one, and it's part of this performance contract around advanced real-time monitoring and supply chains. I'm not going to go too much in depth with that, but you guys can read a bit more about it on this link on our webpage. The first webinar was sort of an introduction to supply chains in Industry 4.0. Obviously, this one today is about maintenance in supply chains, and next one is going to be some examples of value creation with IoT in supply chains. My colleague Martin Kærgaard will be talking there. And then the last one will be around potential of monitoring with production and semi-finished products, focusing on pharma and medical, with Henrik Granow as a guest speaker. Along the way, I thought there was more, but sorry. Along the way in the webinar, if you have any questions, feel free to ask them, but post them as a comment in here in Teams, and then we'll get back to you on the questions. And I can see all of you are already very used to having these online meetings, but please keep your microphones and camera turns off. And then I'll pass the torch to you, Michele.
Yes. Thank you, Mikkel. Good morning, everybody. As Mikkel introduced, I'm going to give you a very quick overview, about 20 minutes, regarding maintenance today and some of the new value creation opportunities that digitalization is bringing on the table today. First of all, the role of maintenance. In the past 20 years, maintenance became a key topic for manufacturers, since it emerged as one of the main cost drivers regarding production costs. It came out in the past years that in general, maintenance operations and their cost regards about between 15 and 40% of production cost, and in some cases they reach up to 60%. Well, 65% of these maintenance costs are actually related to unnecessary or improper maintenance. Therefore, we have a lot of potential improvement and potential production cost reduction. However, this journey, the intention behind maintenance improvement, is not only related to direct costs, so to the reduction of these production costs, but also concern and also answers the need for competitiveness related to, for instance, the need for shorter delivery times increased by increasing asset availability, the need for higher and higher and higher quality standards, so about keeping quality, production quality under control, the need for becoming more cost efficient, increasing the lifetime of our production equipment, of our assets, also enabling a sustainable effect, and finally keeping the working environment safe. There are different ways we have to deal with maintenance, and we call them maintenance policies, and these maintenance policies are divided in two main families. On one hand, we have corrective maintenance policies. What does it mean? It means that we are waiting until something breaks, and then we are dealing with the problem. They are both either deferred policies or immediate policies, which means in the deferred case that we are waiting for failure, and then when something happens, we are trying to figure out what it is, how we can solve it, order the right components to solve it, calling the right people to solve it, and so on. While the more advanced case, we have immediate type of corrective policies, which means that we are actually prepared, and when something happens, we are fairly quick in solving it. The second family is concerned preventive maintenance policies, and it's what we are talking more about, and they start with time-based maintenance, which is simply maintenance based on a predefined schedule, and this schedule is coming from either machine vendors that are suggesting us every X weeks you should change this component or that component, and is also coming obviously from our own internal experience. At a second level, we have condition-based maintenance, which means that instead of having a schedule which is coming from our experience on our vendor suggestions, we are collecting data from our equipment, from our assets, and figuring out based on the value of the parameters we are monitoring when it's worthwhile to perform maintenance activities. For instance, we are monitoring the DC consumption of the motor because we know it's a fairly relevant factor, and when this DC consumption is going above a certain threshold, we perform maintenance activities. On top of that, we have what we call predictive maintenance, which is also based on data we collect from our equipment. But on top of what we discussed for condition-based maintenance, we also have machine learning algorithms that makes possible for us to recognize some failure patterns, identify which parameters were monitored and which values we had, and then try to forecast when the next failure will happen. And this makes actually possible for us to build our maintenance schedule optimally. The tendency is clearly today to go from corrective type of maintenance policies to preventive type of maintenance policies. And especially what we see today is a strong focus in the transition between time-based maintenance and condition-based maintenance. There are a number of tools, of very well-established tools that we use in the manufacturing world, we use to ensure effective and efficient maintenance. And I just collected two of them here, and one is the FMEA or FMECA, so the failure mode effect and criticality analysis, which is an assessment of the criticality of different types of failures based on three parameters: on their detectability, so how easy is to detect them when any failure, any error happens; based on their severity, so how severe, how much damages they cause when they happen; and occurrence, so how frequently they happen. And this is actually used extensively to identify what are the different maintenance needs we have in our production and to prioritize them. Another tool we extensively use, in particular for time-based maintenance, is the computerized maintenance management system, or CMMS. This is an asset management software which is linking the bill of material, our components to be maintained, their maintenance needs, and the spare parts stock to outline an optimal maintenance schedule that we have to follow. So it provides the maintenance team with the right overview for performing their maintenance activities. However, we still have plenty of questions going on. For instance, when is it best to maintain my assets? Am I doing too much maintenance or too few maintenance? What is the optimum? How much value could I get if I improve the way I do maintenance, and so on? And the whole digital transformation agenda today is acting as a tool, as a set of new tools that make possible for us to improve the way we do maintenance. And the big foundation is, like what we discussed the last time, these extensive connectivity capabilities and data availability within our factories and across supply chains. And these try to answer these questions. How? By facilitating, by catalyzing, by enabling the traceability of different critical components in different machines in our production or at our customers. The measurement of their operating conditions and component condition, the recording of failures that we experienced, the estimation of the asset's remaining lifetime, the quantification of failures' impact on different parameters such as cost, quality, and speed, the formulation of improvement initiatives, and so on. The common denominator is that all these new possibilities are enabled by the availability of data from our equipment. This is not new. This was possible yesterday. The new thing is that today is way more accessible. It's easier and it's especially cheaper. How do we get all the data from our equipment? There are three possible scenarios. These come from a good case study that our colleagues from the University of Bergamo did. And first scenario, data is generated by sensors that are embedded in our equipment. We have a machine, we have a number of sensors that make the machine functions, and we collect data from them. The second scenario is that data is generated by sensors that we add on the equipment, and we connect these sensors to our PLC. And the third scenario is to have data that is generated by sensors that we add to the equipment, and they act completely independently. So we collect data wirelessly.
Michele, a quick question. So these different ways of collecting the data, does it say anything about the kind of data you get out, or sort of the resolution of the data, or what?
Let's say that the big difference is that we know that most of our equipment has its own PLC, and many sensors are collected to these PLCs, and we collect already many data. The connection of, for instance, sensor that we add on top of the machines and they operate independently give us the chance to have additional data and to, for instance, support us in identifying additional parameters that could be very interesting for us. And we can get way more specific having this possibility also, not only being limited into connect to our PLCs.
So this is also something that we would expect to see even more of, For example, with more availability of low power wide area network connections and stuff like that.
Yes, to be able to integrate sensors, for instance, on our equipment to have additional information that support us in performing better maintenance. Yes, it's something that will definitely increase in the future.
Cool.
What are the main application cases coming from the availability of these data? When we talk about service and maintenance and the monitoring of equipment conditions, we have three main application cases. And one is the improvement of the maintenance policies. So we went through in the beginning of this presentation these different maintenance policies, and one of the main activities is to improve them. So at the moment, especially concerning the transition from time-based maintenance, so having a schedule, a predefined schedule-based maintenance, be able to perform maintenance activities when we actually need to perform them, when our equipment has some issues. This is going to provide a solid foundation for transitioning towards predictive maintenance. There is a big fuss today about predictive maintenance and how everybody is doing predictive maintenance. Actually, it's something that very few companies are doing, and very few companies are able to scale up because it requires a higher degree of maturity. Second, the improvement of reactivity when we need to support, when we have support operations. We know that failures are of stochastic nature, means that no matter what, at some point they will happen. And we need to be able to act quickly when they happen. And the third main application case concerns problem analysis. Looking back, looking at what we experienced in terms of unplanned failures and try to figure out what was particularly critical and significant and where we should start from when we want to improve our equipment. I have a very short industrial case to try to exemplify what I just said. I think this is a very good case to make an example because it collects two out of these three application cases. And it's a project we ran a couple of years ago together with a Danish automation solution provider, which produces automation cells, automation solutions. And the key order winner for them is the performance of their service operations. Since they have to service about 1,000 automation solutions that they install globally, both in Europe and overseas. And what they wanted to do was to improve their service operations using IoT. And their two main goals were to support the reactivity of their support operations. So when something was happening at their customers using their automation solutions, they wanted to be very, very quick in solving these unplanned stops. And secondly, they wanted to be able to improve proactively the performance of these automation solutions, analyzing what happened in the past year, 2 years, and figuring out what was more significant to be improved and how to improve it. We developed an IoT solution, a digital platform that was capable to collect data from their PLCs and from different sensors, to process them, store them, analyze them, and finally visualize them. And the main building blocks, I will not go in depth into this, but the main building blocks were data generation and action block. In this case, sensors were embedded in the equipment. A data transmission block, we had a gateway transmitting data using OPC UA. We had some data storage. First, we use a Festo Energy database and then a SQL, Microsoft SQL Express database. A data analysis block where we use Microsoft Azure as a cloud computing platform, and a data visualization part where we use Microsoft Power BI and Power BI app to visualize the different data and have different alarms. Well, this was in the end used for support the maintenance team in their decision-making processes. A demonstration of that, before scaling it into their automation solutions, we actually demonstrated this solution infrastructure in the Smart Production Lab at our Aalborg University colleagues. And here you can see the dashboard, part of the dashboard that we developed, where you can see the model of the production line we were monitoring, and on the left, the database of the recorded errors. And you can see that the 5 components we are monitoring are all green. We had no error here. When we experienced an error, which we induced, we received an alert, in this case via email, that redirected us to the right dashboard of the automation solution, and made possible for us to, first of all, visually see the red component, so the component that had a failure, and then on the left in the error database, be able to see which type of error happened and when. So this was a demonstration for the company we were collaborating with, because this provided them an idea of when and where unplanned stops were happening and what was causing them. So helping them in figuring out how to solve them. A byproduct of that was the availability to collect all this data and build a database. And by doing that, it was possible to analyze, post-process and analyze all the collected errors. And after they applied it, they actually figured out that one of the errors, you can see it in the bottoms, one of the errors was causing about 50% of all the downtime related to their automation solutions. And this was a very good information for them, because it provided them first with an idea of what they had to improve, and second of an idea of how much was the improvement potential. Now, to conclude, from a cost perspective, when we think about using IoT to improve our maintenance operations, we remember that we are going to address this 15 to 40% production cost potential. We often think about improving maintenance, making an investment, because in this way we will reduce the downtime cost, so the cost related to the unavailability of our production equipment, because it's not working. So if we improve maintenance, we will reduce downtime. Good. So we will reduce the missed profit, missed profit caused by capacity loss, and we will reduce our image damages due to the fact that we will have longer delivery times and lower quality and so on. We experienced also companies that told us, well, but we really don't have that much downtime, is fairly low. And the comment here is always, but how much do you spend for your maintenance activities to have zero downtime? Because maybe you're doing way too much maintenance. So this is the second family of costs that we need to take care of, and it's the resource cost. Meaning the cost of the resources that we deploy to perform maintenance initiative. And we talk about the time needed for reparations, the people needed for these reparations, and the spare parts that we need to deploy. And we know that 60% of these costs is actually due to unnecessary or improper maintenance. So once again, when we think about improving the way we do maintenance using IoT, we need to remember that yes, we address reduction of our downtime cost, but also we have to focus and address a reduction of our resource cost. Thank you. If you have any questions.
Thank you very much, Michele. Very interesting.
Thank you.
We don't have any questions so far, but I thought that maybe we could talk a bit about, so you say not too many companies have this or any methods for doing this implemented already. How to start? How do you get started? How do you figure out where the biggest potential lies? And do you have any thoughts? I know you do.
Yeah. Yes. First of all, we have to say that there are very few companies that are already really not only piloting but integrating in their maintenance operations predictive maintenance, adopting a predictive maintenance policy. But these are the most advanced ones, the most mature ones. In general, we see, as you mentioned, we see companies that are still not able to go from time-based to condition-based, and many small and medium-sized companies, they're still at a corrective type of maintenance policy. How to start? How to start is a lot about, we have to be systematic when we address these projects. So one important thing is to have a very clear overview of what our maintenance operation consists of, how much time is dedicated to each operation, how much time we waste, how much money we waste. And this, first of all, can give us an idea of what is the potential for our specific company. Is it worthwhile to change our policy? And then there are all these well-established tools like MECA analysis to identify what is more critical. And this is also another initial step to figure out where should we start improving maintenance.
Okay, so the first thing is actually getting knowledge, in-depth knowledge, and of all of the supply chain.
Yes, exactly.
Yeah.
And secondly, what we also try to do here a lot when we address this project is to start with very small scale demonstration projects. So we build our little box with few sensors that is monitoring our very critical parameters on our very critical machine, and then we start figuring out how we should build this solution, and we start seeing also how much this solution is impacting our maintenance operation, how much are the benefits. And little by little, this makes possible both to develop the solution and to develop our business, different ways to do maintenance, change our policies, and little by little scale it up. One important thing is to move on step by step. We saw how predictive maintenance is a direct consequence of condition-based maintenance. So it's very important to move step by step, not make leapfrogs, jumps.
Yeah. So I can see we have a question. So what is, Martin, he is asking, what is the best way to get data out from machines that does not have any connectivity already? What's the best way?
What's the best? That's a
very good question.
It really depends on the context, but I can give you a few examples. For instance, if you have your PLC, which doesn't have any connectivity, but you have your PLC with your sensors connected to the PLC, and you know that the data you need to support your maintenance activities are already collected in your PLC because you already have the sensors in place collecting this type of parameters, then one thing that you do is to connect your PLCs to the internet using some gateway softwares, and there are plenty of them. I will not mention brands, but there are plenty of gateways that you can add externally to your PLC and make possible for your PLC to ship the data to the cloud, for instance. Other ways, if you don't have these sensors embedded in your machines, are to add these sensors by yourself. We saw the example, and there are several plug-and-play wireless sensors that you can on top of your machines. For instance, you can put a proximity sensor that simply counts how many products are being produced and when. And these sensors have their own wireless module that is able to ship data to the cloud, where you're able to collect them and visualize them. So there are different opportunities, but that slide with the 3 opportunities could be a good example for you. But yes, if you collect them to the PLC, there is the possibility to ship data from not connected PLCs to the internet using external gateways.
And just an added point, I say you'd always want to start with what kind of data is needed for you. What do you want to use the data for? And from that, then look at which sensors, which opportunities exist already on the markets.
Yes.
And potentially, if it doesn't exist anything, you can create one yourself, but it's going to be a bit more expensive. Cool. I think we are going to wrap it up from here. Thanks a lot, Michele, and thank you all for participating. I hope you found it interesting. If you missed some of the presentation or want to see the one from 2 weeks ago, they're available. This one is going to be available in a few days, and the other one is already available online. And remember, if these next 2 webinars are interesting, you are all very welcome to sign up and join. Yeah, that was it. If you have any questions or anything, feel free to keep in touch, reach out to us.
Yes, if you want to follow up a bit more in depth on these discussions, of course, feel free to send an email and we can discuss it.
Yeah. Cool. Thanks, guys. Take care and have a good day.
Good day.
Bye.